Time complexity is a issue that computer scientists often think about, and the reason why we think about this is because we should always have an idea of how long an algorithm is going to take, because that's what time complexity tells us. It tells us, a best case scenario, average scenario, worst case scenario. How long is an algorithm going to take if it's considering n elements? And this chart here shows different time complexities noted by big O notation. So then you got this big O and then a number inside of the parentheses. The number in the parentheses is the time complexity. Log n, I'm not sure if you're familiar with log, but it's basically the inverse of, I don't know, it's a very low number, right? So if you drop in log of log of 1, it gives you a small fractional number. You drop in log of 1,000, it gives you back 3, right? So log is a very low number, and if your algorithm had a time complexity of log n, it would be very fast, right? You can see it's down here, right? And then we have a time complexity of n, which means for every element that you are considering, you need that your algorithm needs to perform one instruction. And so this is the time complexity of an algorithm that runs on big O of n, right? And then we have n times log n, which is this line here, and this is a pretty fast algorithm, right? When compared to n squared goes like this. Up is an exponential curve, and then you have n to the 3, n to the 4, you have 2 to the n, and then n factorial time complexities. And so you might be asking yourself, like, why is this important? Who cares? We have extremely fast computers. We have GPUs that are run insanely fast, and so why do I care about this small little program that I'm making, if it's slow or if it's fast? And basically all of the software in the world is not just running once, it's running multiple times. And so increasing the time complexity of an algorithm would save time, every time it's run. And so another thing is that if you have an algorithm that, let's say, all the computer scientists in the world, all the mathematicians in the world agree has a worst case time complexity of n squared, right? And so all of the implementations around the world involve the algorithm that has a time complexity of n squared. Let's assume that that's the case, and that it's discovered that no, it's actually there's an algorithm that an algorithm that performs the same purpose has been found that runs at n log n, right? Well, then that means that every time that algorithm is run around the world, you're saving that much time. All right, and so that's kind of what we're talking about here when we talk about time complexity. And with regard to matrix multiplication, that those operations happen all the time, right? When you're talking about in the software world, and so increasing the time complexity has a direct effect on the real world, and in a very powerful way, right? And so that's big O time complexity. We'll talk about a little bit more detail and get into some real world examples in the next video.